Hello, good morning viewers. This is Dr. Gunamani Jana and you are watching video with me on object-oriented analysis and design using unified modeling language, and specifically we are going for this module 3. In this module 3, we'll be covering the design patterns. The software design patterns, as you know, these are the essential tools for developers providing proven solution to common problems encountering during the software development. Here, we explain concept of design pattern, their importance, and explores various types including the creational design pattern, the structural design pattern, and behavioral design pattern. By understanding and applying these patterns, developers can create more robust, maintainable, and scalable software system. Understanding and applying these patterns can significantly enhance our software development skills. That is the purpose we are going for the software design pattern. Then what is this design pattern? Design patterns are reusable solutions to common problems in software design. While we are going for the software design, so we need some solutions or some to some common problem. We need a solution. So if you can make it reusable solutions, then our problem is sorted out. And they represent best practices used by the experienced object-oriented software developers. So it is anybody starting or starting from the scratch, they don't any face any problem because this design pattern is already prepared by experienced object-oriented software developers. That is the highlight. Then designing patterns provides a standard terminology and are specific to particular scenarios. And what is the key characteristics of the design pattern? We have the following key characteristics. One is the reusability, what I told you previously. Patterns can be applied to different projects and problems, saving time and effort in solving similar issues again and again. Then the standardization. They provide a shared language and understanding among developers, facilitating communications and collaborations. So this is a standard. So different people do different things. No, that is a common or generalized standardization things are there, they follow. Then the efficiency. By using established patterns which are already proven, developers can avoid reinvestment in wheel, leading to faster and more reliable development. Then is the flexibility. Patterns are abstract solutions that can be adapted to fit various contexts and requirements. This is the thing. Then, what is the regions? We learn these design patterns. There are several regions. First one, it improves the quality, code quality. So design pattern help in creating code that is easier to understand, maintain, and extend. That's why they promote best practices and provide solutions that have been tested and proven effectively. This is the reason. This is one of the reason why also we learn this design pattern. Second one, enhance problem solving skills. Problem solving skills is enhanced here. Learning design pattern equips developers with a book of standard solution to common problems because there are a number of solutions to a same problem, but we need some standard solutions. So this enables them to quickly and effectively address similar challenges in various projects. Third one, then we go for this promote reusability and efficiency. By applying design patterns, developer can create a reusable components that can be used across the multiple projects. So this way, the reusability and efficiency also improved. Then learn from experts. These design patterns are derived from the collective experience of skilled developers and architects. So learning these patterns allows developers to benefit from the wisdom and the insights of industry experts. This is the reason why you go for the design patterns. As I told you that there are three category of design pattern. One is the creational design pattern, second one is the structural design pattern, and third one is the behavioral design pattern. And the single design pattern in the right hand side you can clearly see here. So we have divided into five. One is the singleton design pattern, second one is the factory method design pattern, third one is the abstract factory method design pattern, fourth one is the builder design pattern, then the fifth one is the prototype design pattern. So there are five number of design patterns here. Then the factory method design pattern, the factory method patterns is used to create object without specifying the exact class of object that will be created. So we are starting with the factory method design pattern. What is telling? Here, it creates objects without specifying the exact class of object that will be created. without knowing the classes, it starts creating the object. So this pattern is useful when you need to decouple this creation of an object from this implementations. When I want to decouple the creation of object from the implementation, that case we go for this factory method design pattern. Then what is this abstract factory method design pattern? This abstract factory method is almost similar to the factory pattern and is considered as another layer of abstractions over the factory pattern. The abstract factory pattern work around a super factory which creates other factories. Okay. So it is one layer. It is just like a super class creating a number of classes. That same concept it is there. Then coming the singleton method of design pattern. The singleton method or singleton design pattern is one of the simplest design pattern and most widely used. It ensures a class only has only one instance and provides a global point of access to it. Okay, we'll discuss in details. We'll have some minimum knowledge about these things. Then we'll go for the details. Then coming the prototype method of design pattern. The prototype allows us to hide the complexity of making new instances from each client. So only I want to use that one, hiding the complexity. For that case, I go for the prototype. And the concept is to copy an existing object rather than creating a new instance from scratch. Some things, something that may include costly operations. So the existing object acts as a prototype and contains the state of the object. Okay. So this is the things. This is the reason we go for the prototype design pattern. Then the builder method design pattern. This is the last design pattern under this creational. So builder pattern aims to separate the construction of a complex object from its representation. One is the representation, second one is the construction. So this builder separate the construction from the representation so that the same construction process can create different representations. Is used to construct a complex object step by step, and the final step will return the object. Okay, these are the things you will understand. Then we are moving to the second category of design pattern, that is the structural design pattern. The structural design patterns are concerned with how classes and objects are composed. There is created, here is composed. The structural design patterns are concerned with how classes and objects are composed to form larger structures. The structural classes patterns are used, they use inheritance to compose interfaces or implementations. So the different types, we are having 7 type of structural design patterns. First one is the adapter design pattern. Second one is the bridge design pattern. Third one is the composite pattern. Fourth one is the decorator pattern. Fifth one is the facade design pattern. And sixth is the proxy pattern. And seventh is the pivot pattern. We'll discuss one by one. First, we go for the adapter method design pattern. The adapter method design pattern converts the interface of a class into another interface clients expect. Okay. So this adapter lets classes work together and that counts otherwise because of incompatible interfaces. So when two things are incompatible, we need an adapter to make it. For example, I have given, suppose I am using an adapter in my computer devices or things, so it is that to the source is 240 voltage and I want only 9 voltage or 12 so I need an adapter to reduce and to make it compatible. That is the purpose we can understand. Then the bridge method design pattern. The bridge pattern allows the abstraction and the implementation to be developed independently. One is the abstraction, second one implementations. They are allowed to be developed independently, nobody depending on others. And the client code can access only the abstraction part without being concerned about the implementation part. Okay. So the client can access only the abstraction part, but the details implementations they cannot access. This is the bridge method design pattern. Third one with the composite method design pattern. A composite pattern is a partitioning design pattern and describing a group of objects that is treated the same way as a single instance of the same type of objects. So the intent of this composite is to compose objects into tree structures to represent part to whole hierarchies. Okay. So then we go for this decorator method of design pattern. It allows us to dynamically add functionality and behavior to an object without affecting the behavior of the other existing objects. So it dynamically adds behavior or functionality without affecting the existing object with the same classes. We use inheritance to extend the behavior of the class, and this takes place at compile time, and all the instances of that class get the extended behavior. And the fifth one is the facade method of design pattern. Facade method design pattern provides a unified interface to set of interfaces. Say suppose there are number of subclasses, so interface is required. It provides a unified interfaces. We call it as the packet. And packet defines a high-level interfaces that makes the subsystem easier to use. And the sixth one is the flyweight method of design pattern. This pattern provides way to decrease object count, thus improving applications required objective structures. Flyweight patterns. This is used when we need to create a large number of similar objects. We go for the flyweight method of design pattern. Seventh one is the proxy method of design pattern. Proxy means in place of, so representing or in place of or on behalf of are all the literal meanings of proxy that directly explains the proxy and design pattern. Proxy are also called surrogates. Okay, surrogates, handles, and wrappers. They are closely related in structure but not purpose to adapters and decorators. So this is about the structural design pattern. Then we are going for the behavioral design pattern. The behavioral design patterns are concerned with algorithms and the assignment of responsibilities between the objects. And the behavioral pattern describes not only just the pattern of object or classes, but also the patterns of communication between them. These patterns characterize complex control flow that is difficult to follow at runtimes. So, what are the 10 number of design patterns we are having here? One is the observer design pattern, second one is the strategy design pattern, state pattern, command pattern, chain of responsibility, template pattern, interpreter pattern, visitor pattern, mediator pattern, and memento pattern. These are the 10 number of design patterns available under the behavioral design pattern. So, we'll discuss one by one. First, I'm going for the chain of responsibility method of design pattern. Here, chain of responsibility pattern is used to achieve loose coupling in software design, where a request from the client is passed into chain of objects to process them. So, what is loose coupling? What is the tight coupling? In the class, I already explained you. So, for example, I particularly say this person has to do this work. Loose, it is not loose tight coupling, but I say some of the student in the class they can do it is loose coupling. I'm not directly depending on a particular person, but I'm telling that somebody can come and do. Later, the object in the chain will decide themselves who will be processing the request and whether the request is required to be sent to the next object in the chain of. Say suppose first person fails, then it can be sent to the second person in the chain. Otherwise, the problem is sorted out, then stop that process. Then command method of design pattern. The command pattern is a behavioral design pattern that turns a request into a standalone object containing all the informations about the request. So this object can be passed around, stored, and also executed at a later time. Then in the interpreter design pattern, interpreter patterns used to define a grammatical representations for a language and provides an interpreter to deal with this grammar. So as I told you that we are having 12 number, 10 number of here. The fourth one is the mediator design pattern. It enables decoupling of objects by introducing a layer between so that the interaction between objects happen via the layer. One layer is there, so it's just it acts as a mediator between two parties. Then the memento method of design pattern, it is used to restore state of an object to a previous state. Okay, you want to roll back, you have to go to the previous state. As our applications is progressing, you may want to save checkpoints in your applications and restore back to those checkpoints later intent to memento design pattern. Then we are going for the observer method design pattern. It defines a one-to-many dependency between objects so that when one object changes its states, all the dependents are notified and updated automatically. This is we call the observer method design pattern. Then in the state method design pattern, a state design pattern is used when the object changes its behavior based on the internal states. Okay. So if you have to change the behavior of an object based on this state, then we have to go for the state method design pattern. The eighth one is the strategy method design pattern. The strategy method design pattern allows the behavior of the object to be selected at runtime. It is one of the gang of four. In the gang of four, the strategy method design pattern is one among them, which are widely used in object-oriented programming. These strategy patterns, these are based on the idea of encapsulating a family of algorithms into separate classes that implement a common interfaces. Okay. So then we go for the template method design pattern. Template method design pattern is also defined as the algorithm as a skeleton of operations and leave the details. You know the template just in a common format or the provided format. How we do. And the visitor method design pattern is the last one in the behavioral design pattern. It used when we have to perform an operations on a group of similar kind of object, then we go for the visitor method design pattern. With the help of visitor pattern, we can move the operational logic from the objects to another classes. So this is all about the details. Then we'll be moving to the single turn design pattern in our next video. Thank you for watching this video. If you like, to share this video with others, and also don't forget to just subscribe it. Thank you.